Hello viewers, you're welcome to my YouTube channel Mathematics Made Easy. So into this video we are looking into a very important concept in mathematics, which is the Legendre polynomial. It's very important. Okay, so if you're new to this channel or if you're watching this video and you haven't subscribed, please don't forget to subscribe, like, comment, and also share. Okay, thanks for doing that. All right, so let's dive into the work. So how are we going to express this given function 3x raised to the power of 2 plus 2x plus 1 in terms of the Legendre polynomial? Alright guys, it's very easy. So I will firstly write out the general term of the Legendre polynomial. And here is the general term of the Legendre polynomial. So we have Pn of x is equal to 1 over 2 raised to the power of n multiplied by n factorial. Then multiplied by the nth derivative of x, then of x raised to the power of 2 minus 1, then raised to the power of n. Okay, so that's the general term, or the general representation of the Legendre polynomial. Now, how are we going to express this given function in terms of the Legendre polynomial? That's the question. So if you look at this function, the power of x here is 2. That shows that n will be equal to 2. The power of x here is 1, that shows that n will be equal to 1 here, and the power of x here is 0 because x raised to the power of 0 will give us 1. So that shows that the value of n here will be 0. Now, this is what we are going to do. That is, we are going to find when n is 2, that is, we're going to find p2 of x, we're going to find p1 of x, and we're going to find p0 of x. Okay, now let's get started with that p2 of x. That is when n is 2, so we have p2 of x. Okay, so which is equal to 1 over 2 raised to the power of 2 multiplied by 2 factorial. Then we are going to differentiate this how many times? That's 2 times. Okay, the square over the x squared, then into brackets x raised to the power of 2 minus 1, then raised to the power of 2. Alright, so 2 raised to the power of 2 will give us 4, then 2 factorial is 2 times 1, which is 2. So 4 times 2 will give us 8. So we have 1 over 8, the square of the x squared. Alright guys, so if we expand x squared minus 1 raised to the power of 2, we're going to have x raised to the power of 4, then minus 2x raised to the power of 2, then plus 1. Okay, so we expand that, we are going to have this. So let's differentiate these 2 times. So we have p2 of x is equal to 1 over 8, then into bracket d dx. That is, if we differentiate these ones, what are we going to have? 4 times x, then raised to the power of 4 minus 1, which is raised to the power of 3, minus 2 times 2, then multiply by x raised to the power of 2 minus 1, which is x. Then if we differentiate 1, you have 0 because a constant. Okay, then you differentiate for the last time, so we have 1 over 8, then into bracket 4 times 3 will give us 12, then x raised to the power of 3 minus 1, which is 2, then minus, if you differentiate 4x, you have 4. Okay, then we can see that 4 is common here, so we can factor out 4. So if we do that, so we have p2 of x is equal to 4 over 8, then into bracket 3x squared. Okay, then minus 2, minus 1, we factor out 4. Okay, then this is gonna give us 1 over 2, then into 3x squared minus 1. That is beautiful. All right, so that is p2 of x. We are done with that. Now let's find p1 of x. P1 of x. So that is next thing we want to do. So let's use another ink for that. So p1 of x, that is when n is equal to 1. So we are going to have 1 over 2 raised to the power of 1, then multiply by 1 factorial, then multiply by d dx. That is, you are going to differentiate this just once, x squared minus 1. And 2 raised to the power of 1 will give us 2. 1 factorial is 1 times 1, which is 1. Okay, then we are going to have 1 over 2 into bracket. So we differentiate x squared minus 1, so that's going to give us 2x, and we can see 2 we cancel out x, 2 we cancel out 2, and then we are going to have x. Okay, that is p1 of x. And then if we do that for p0 of x2, you are going to get 1 for that. Let's check p0 of x. P0 of x, that is when n is equal to 0. So P0 of x, so we are going to have 1 over 2 raised to the power of 0 multiplied by 0 factorial, then d raised to the power of 0 over dx raised to the power of 0, then into brackets x raised to the power of 2 minus 1 raised to the power of 0. So everything here is just 1. Then 2 raised to the power of 0 is 1, 0 factorial is also 1, so everything here is also 1. 1 times 1 will give us 1. So we have p naught of 0, p naught of x is equal to 1. So since we are done with that, we can now find, or we can now express the function in terms of Legendre polynomial. So p naught of x is 1, p1 of x is x, and p2 of x is 1 over 2 into bracket 3x squared minus 1. Okay guys, so let's complete the solution. So let's move to a new page so that we can complete the work. A new page. Good. Now that shows that we can write the given function f of x in this form. A, that's a constant, multiplied by p2 of x, then plus b, that's another constant, multiplied by p1 of x, then plus c multiplied by p naught of x. Now that is f of x will be equal to a, so p2 of x, which is 1 over 2 into bracket 3x squared minus 1. Let's check, is that what we got? Let's check that. Yeah, that's good. So plus b into bracket p1 of x, we got x for that, and then p naught of x, we got 1 for that. Okay, so now if you expand this will be a over 2 into bracket 3x raised to the power of 2 minus 1, then plus bx plus c. So this will be equal to 3 ax squared over 2 minus a over 2 plus bx plus c. Now minus a over 2 and c, they are both constants, so I can bring them together. So then we are going to have 3a over 2x squared, okay, plus bx, then plus c minus a over 2. So guys, so we can equate the function to be equal to this, which is 3x squared plus 2x plus 1. 3x squared plus 2x plus 1. Then we equate. So 3a over 2x squared will be equal to this. Since this the coefficient of since x squared is the coefficient of 3a, you can see x squared, we equate them. So we are going to have 3a over 2x squared is equal to 3x squared. So we can see x squared, we cancel x squared, and then 3 will also cancel 3. So what you have now is a over 2 is equal to 1. So we cross multiply, so then we have a is equal to 2. So that's the value of a is 2. Now let's find the value of b. Okay, so you can equate bx to also be equal to 2x. All right, so we have bx is equal to 2x. So definitely the value of b is equal to 2. And last but not least, c minus a over 2 will be equal to the only constant here, which is 1. And then we already know the value of a, which is 2. So we're going to have c minus 2 over 2 is equal to 1. And 2 divided by 2 will give us 1. So we have c minus 1 is equal to 1. Then therefore c will be equal to 1 plus 1, which is also equal to 2. That is, the value of a is 2, the value of b is 2, and the value of c is 2. So we can now input that into it. Then we have, finally, let's use a yellow marker for that. Finally, we have f of x is equal to the value of a is 2. So we have 2 p2 of x. The value of b is also 2. So we have 2 p1 of x. And the value of c is also 2. We have 2 p naught of x, and that completes the solution. So if you like this kind of video, please don't forget to subscribe, like, comment, and share. Thanks for watching. See you next time.